All right, so she said section 6.5?
6.4.
6.4? 65.
Oh yeah, that one.
That, somebody knows that problem.
And also 7.1, number 50.
All right, hold on. Don't do that to me. I can barely keep one in my head. 65, 64.
Yep.
Okay.
55.
55. Okay. Eventually I get it.
I took out a -5.
Yeah, so 55, 64. This is negative 80. 86 plus 45.
Oh wait, it says 45?
Yep.
Oh, I wrote down 25.
Oh,
That's
free.
probably my problem.
That'll
There you
never
go.
work. But a good general thing to notice is you should take the negative out if the variable piece is a negative. You should take that out. You always want that first thing to be positive. It's going to make everything a lot easier to deal with.
And then make the second one negative, right?
Yeah, if you take a negative out. So what number could come out?
6 or 5.
5? No A's can come out, right? Because he's got no A's. Poor little dude. 5 goes into 80. 1686 plus, in the case of actually like a minus 9. I like it. And what's this? What form is that going to be?
483.
Yeah, it's a difference
Squares.
of squares. I love it. So the general thing to realize is that just because you did something doesn't mean you're done, right? You did something and the rest can still go further. You always want to check that.
I was only giving the squares as opposed to the fact.
Totally. 4a cubed 3.
So it's difference in cubes.
No. I can cut everything in half. 16 is 4 times 4. A6 is A3, A3, A9 is 3, 3.
Where does the -5 go?
It's right there. And as you do more stuff, it just sits right there.
Okay.
Yeah. So don't lose somebody. You're supposed to be able to multiply your final answer. You're supposed to multiply back out to this. So if you lost the -5 somewhere, that ain't going to work. Your answer better multiply back out to be the beginning. That's what you mean when you do this. You're rewriting that expression a different way. Hopefully in the right way. Anything else from homework stuff? Oh, and then we'll come back.
Oh, 70.
7.1, number 50. That's fine.
7-1.
I was just going to call it factor.
That's what I-
Denominator.
7-1 number 50, 55 again?
Yeah. Can you factor the bottom?
Nope.
Yeah, so it's prime
So no, it's not prime. I mean, the bottom is prime, sure, but you can do something.
to the top.
Remember what I said about if there's a cube problem in these simplify fraction problems, you do it first. The bottom is going to be the big dude from the top. Top is GCF, right? Yeah, the top GCF, and then you have a cube left. So this is 55 in section 7.1. Why I had to write that note right there. That sucks. So 55 and 7.1 is, what was it? 24. It's this guy. It said, simplify this. So can you imagine, you can see yourself doing this. You can see yourself going, let me start here. That's easier. Let me do this. And then you're like, come on, it's got to work. Come on, it's got to work. And 10 minutes later, I'm like, all right, that's done. That's time. You're like, I didn't even do one of these damn things. There's a cube. There's a cube right up there. Is it cubes yet? No, there's stuff in the way. But there's a cube problem. You do him first. Because the big dude might be what this is, and that's exactly what's happening in this problem. So what do you do first on the top? Take out a 3. And then you can see what's left is a cube. So now you attack this guy. Little dude, big dude. The big dude's going to be this. So the whole thing goes away. You don't have to try. Thank God we don't have to break it up because it can't be broken up. I lock it. Yeah.
7.348.
Oh, did I sign those? Oh, let's see. Do that. 48. So we have the homework sheet right there. What was the assignment for 7-3?
7-3 was,
Page 526, 5 through 35, every fifth one.
5 through
35?
35. So why are you doing 48? Was it 5 through 35?
5 to 35 and 45, 48, no?
Maybe.
That was 75.
Oh, okay. Yeah. The reason I say that is I hate that 48. I hate that question. I was like, why would I have assigned that question? That question is kind of like, instead of saying just add these two, they kind of say find the lowest common multiple between 6 and 9. I'd rather do it in a problem where I could actually do it for a reason. So they're like, find the lowest common multiple. No, I'd rather have it in a fraction so I then have something to do with it. So I hate assigning those questions. That's why I'd be surprised if I did. So there you go. Don't worry about it. Yes?
Factor 6.4, number 70.
Oh, yeah, okay. There's actually a couple of these. Is this one of those? Yeah, this is perfect. Okay. If I didn't get a question on this, I would be very worried. So everybody thank Mason for keeping me not worried. These problems are weird. I kind of said these were going to come, and then they're here, and I forgot about them. So, how many terms are there? You would try grouping, but you immediately see that grouping the normal way doesn't work. So to be honest, what you do is you group it this way. Because look at this. You see that? How do you factor these three? It's got no A. Yeah, so it'll be A, 4, 4. And they both have to be negative. So what's a better way to write this? Something squared minus something interesting. Something squared minus something squared. Difference of squares, right? So that's a different way to group. Normally you group first two, last two. If it doesn't work, the next thing to try is first three, last one. So maybe the first three factors like this. A square, and then you got difference of squares. Freakadelic. We've looked at some of these like this. How does this work? What do you put here and here? Yeah, no, again, I'm going to freak everybody out. There's no A anywhere in here. This has no A in it. It's got an A minus 4. It's got a couple of them. So I put an A minus 4 here and an A minus 4 there. And then B and a B. And in the middle I put... Yeah, okay. Went too far. I did it for you. Shit. But there is at least one more problem like that. So if you try grouping and it doesn't, it's like completely not going to work. Try to group 3 and 1. And it might work like this.
And then would it just be the same for that, like middle term for the big one, and just be the little term?
No, there's no big one. There's no little one, big one.
That's
This is
just
squares. It's
Oh.
a square. Cut in half, minus plus. Done. I'm done. There's no like terms inside, right? A's and B's and 4s. Yeah.
How come you don't make an A plus 4?
I don't have an A plus 4s, that's why. So watch this. Help me out here. How do you factor y squared minus b squared? How do you factor that? How do you factor this?
Y minus B?
Yeah?
Y minus B? Oh, okay.
Y what?
Y minus B, right? Y plus B?
Yeah. Stay with me.
Okay.
All right, what if it would have been, so that's done. What if it would have been a squared minus b squared? Part of your reaction should be, same thing, Jeff, right? That should be your reaction. Well, what would it be? What would it be?
A minus B.
Cool. Whatever this is, There's two of them, so I'm going to put one there and one there. So look, what do I have two of? I have two a minus 4s. I don't have any a plus 4s. So what did I do? I put a 1 a minus 4 there, and the other one there. Minus plus BB, that's where the minus and plus goes. In between that and that, that's where the minus plus goes.
Could you do it, like for the last two terms, take out the negative and it can just be the difference of squares?
Yeah, but then it would never match with anything that this has. No, I'm not saying that that might not work in some other problem, but in this problem it ain't going to work. See, this group doesn't have a damn thing in common with this group. So grouping by pairs would never work. But I mean, that's the kind of thing you try. And you don't freak out when it doesn't work. You just go, well, that didn't work. Let me try something else. Not a big deal. That is a part of this whole thing, is trying something out. It doesn't work. Let it go. Try something else. So our normal grouping method didn't work. Let's try to group it a different way. It is 4 terms. And what did Jeff say? It was 4 more terms. Grouping. I just didn't say what kind of grouping. This is still grouping. You guys okay with that? It's not just semantics. It's the act. It's just the thing you do. Okay. Anything else? Homework stuff? Yeah.
7.1, number 75.
Oh, okay. All right. So let's do this. I like that. I forgot they put that in there. This is going to drive me crazy. Everybody remember this? Quiz tomorrow. Test on Tuesday. So tomorrow I'll have the practice test, all that kind of normal stuff, right? I got to take back some real estate. Okay. Let me build up to that, okay? So somebody remind me, what's the domain of this? Let's give it a function name. What's the domain of f?
Anything but 2.
Exactly, because what do you think when you hear the word domain? Domain means, pertains to what letter? Ooh, pertains. Domain refers to what letter? X, normally X, whatever my input is. So it's all the values I'm allowed to use. So when you see a question say, what's the domain here? You think to yourself, what am I allowed to use? Or maybe, what am I not allowed to use? What am I not allowed to use here? 2. So the domain would be everything not 2. If you really want to be technical, it would be this. I don't know if you guys remember this. Remember that? That's hyper-technical, and that's a lot more writing than this, so screw that. Right? They mean the same thing. Okay, how are we doing so far? Decent. Now, a very interesting question then, and I'm not going to get too deep into this, but I just wanted to give you a little taste of this, is what this shit happens around 2. I'm allowed to use everything except 2. Like I could use 1.99999999999, right? That's not 2. All right, now watch. Somebody, you guys help me out. Who's got the calculators? Or we can do this by hand. Especially because I'm going to help. So I can't put 2 in. So I love this idea. Here's what we do in math when there's a problem spot. What do? We pretend like we're young boys. What do we do when we're young boys and we see something over there like, what the shit's that? What do? We go, oh, let me see. We take a stick. We get really close to it and we go, okay, nothing bad's happened yet. So what do we do in mathematics? We do the same damn thing. 2 freaks this thing out. You can't put a 2 in there. So what's the next best thing? Let's put 2.1 in there. Right? It's sort of like the whole thing, he's touching me. Oh, no, I'm not. I'm just close. So we're not allowed to touch 2, but we can get really close to 2. What do you get when you plug a 2.1 in? You get 1 over 2.1 minus 2. What's 2.1 minus 2? 0.1. 0.1 is 1/10. So this is 1 over 1/10, which is 10. You guys with me? No? If you did 1 divided by 0.1 in your calculator, it comes out of being. What's 0.1 again? Isn't 0.1 1/10? Isn't that in the 10th spot? And what's 1 divided by a fraction? The reciprocal. So this is 10. What if I put 2.01? Get even closer to my sister in the back seat. He's touching me. No, I'm not. You don't like that? Okay, I'm sorry. It's this whole idea of there's a weird thing here. How do we investigate it then? If we go there, we die. It's like a little black hole thing. But we can get really close to it, believe it or not. Not like a black hole. We can get really close to it, we're like, whoa, that's weirdly freaky. But if we go there, we're dead. So what are we going to do? Get a little bit closer. I'm still alive. Let me get a little closer. Let me make sure you guys... So again, what's the one thing I'm not allowed to use in this function? 2. So to go one step further than we have before, a real good question then is, what happens around 2? If 2 freaks this function completely out, what does stuff around 2 do?
You go down, like you use 1.
Yes, 1.9.
Yeah.
So we're getting investigated from the other side. But let's look at this one. Same way that happened before, 2.01 minus 2 is 0.01. What's 0.01? 1/100ths. So the same way this was 10, this will be 100. So you can imagine, as you get closer and closer, this is going to keep getting bigger and bigger. If I were to graph that, here's 2, here's 3, here's 2.1 is 10, 2.01 is 100, 2.001 would be 1,000. So this thing is doing this. Whee! I should have wore that. You shall not pass shirt. That's the whole idea of that, is this thing. It's called a something or other. It sounds like an insult in math. Who knows what this line is called that I drew, this dotted line? It's an asymptote. So this is a asymptote. You guys ever heard of that? Asymptote is something that you can get really close to, but you just can't cross it. You can't get past it.
I can barely hear anything with this thing going on.
Yeah, I gotta go over there again.
Call it an asymptote.
Here, you guys do this while I go rough up. Yeah, I'm like, you're bringing me over here again? Yeah, I need a broomstick so I can just whack this wall.
Es que mi amigo me mandó una Hola.
He looked at me like, oh yeah, there's other people. There's always a chance. I've had something like this happen before. It wasn't exactly this, but it's like, what are you going to do about it? Holy crap, where am I? Okay. So, look what happens. Don't you get like the same thing almost? But what is 1.9 minus 2 now? Negative. Negative 10. So if you put 1.99, oh, get out of there too. You're going to get negative 1 over 0.01. You get a negative 100. So it goes like this on the other side. What would it be? Yeah, let's see. I'm trying to make it accurate, but I guess I don't have to worry about it. So, now, I like this. I forgot that I put this in here because I'd like to give you a little preview of this. You're going to get a lot deeper in this if you get into pre-calculus. But this idea of, okay, it's one thing to say what you're not allowed to use. It's another thing to say, well, what happens when I get close to it? Here's a beautiful visual of why you're not allowed to use 2. It goes insane around 2, right? So what if you put a 2 in, what's the value? Well, it's way up here and it's way down there at the same time. What the shit? So that's a visual of what it means to be undefined, or one way. There's other ways to be undefined. Is that decent? So when they say vertical, I think they said vertical asymptote. So it makes sense. This is a vertical asymptote. So sure enough, you could have these things called horizontal asymptotes, and that's for pre-calculus. Here's a vertical asymptote. Where are they? At all the places you're not allowed to use. Kind of makes sense. So if I had more places that I wasn't allowed to use, there would be more of these things. More of these walls. I always call these walls. Right? I'm also a Star Wars geek, so I'm always like, that shield is still operational. That's a trap. If you don't get that, it's okay. Is that good? Who asked that? Both of you asked that? Does it make sense? So when they say find, determine the vertical asymptotes, that's just another way of saying what x's are you not allowed to use. Yeah. You're like, you could have just said that, Jeff, without all the trap and the stuff and the point one. I know. All right, anything else from homework before we get into old and new stuff?
Is this gonna be on quiz?
The quiz is only 7172. So the quiz is rational expression. So like, it's sort of this, but not, I'm not going to say vertical asymptote. So 7.1 is where we did what values of x can we not use, which is this. This problem just went a little further and said, oh yeah, by the way, that's a vertical asymptote. Freaky things happen there. Right? And also in the quiz, is the rest of 7.1 was reducing a rational expression. We have to factor the top and bottom, kill. And 7.2 is where you have a fraction times or divided by another fraction. But it's still factor, kill. Right? Okay. Anything else from homework? Or general questions? All right, let me give you this. This is related to the discussion we had the other day. The front page, this page with all the colors on it is just numbers. I want you to try a few of those out. On the back is, of course, rational expressions with all the beautiful variables. Well, oh, so here what you did is you actually took a negative one out. You factor -1 out, so -1, that's without the sign change. You actually, that would show me how the signs change. You just got to choose them. But it's got to be a reason.